Fluid continuum. Continuum means the dictionary word is continuous. Continuum or continuous, anything. What is continuous? What is fluid continuum? For example, take a fluid. If we observe that fluid, it seems to be continuous in macroscopic point of view. If you see them, it seems to be continuous without any holes inside. But if you observe them closely, there are number of gaps between molecule to molecule. Every fluid in the universe is distributed in the form of circles, that is distributed in the form of molecules, atoms. That seems to be merely circle. But between circle to circle, there is a void, there is a gap between circle to circle. So every fluid in the universe is distributed discretely, that is a lot of gaps between them. The matter is distributed like circles, here one, here another, like this. Lot of voids between them. But what this continuum concept, what is this continuum, fluid continuum facilitates us, though there are gaps, but continuum helps us treating any fluid continuous without any gaps. It is an assumption that helps us treating every discontinuous fluid as continuous fluid. See, here the matter is distributed in the form of circles, but here once if we apply continuum, that is if we consider the fluid is continuous, then it is not distributed like circles but uniformly throughout the beaker. In this beaker there are a lot of gaps, but in this beaker there are no gaps. Here there is continuum applied, no gaps, not continuum, continuum. And up to what distance, up to what range this continuum is applicable and when it is not applicable. For example, consider three liquids or three fluids: fluid 1, fluid 2, fluid 3. In fluid 1, this molecular mean free path lambda, that is very less, that is the molecule to molecule distance or the gap is very less. In fluid 2, it is little higher. In fluid 3, it is very high compared to 1 and 2. Okay, let us see when or for which fluid continuum is valid and for which fluid continuum is not valid. For which fluid we can treat it is continuous, which is not continuous. Take fluid 1. In fluid 1, it seems to be the gaps between molecule to molecule is almost zero, very less, negligible. In this case, compared to the molecule size, the gaps are very less. So matter is higher than the gaps. So though there are discontinuous, but we can treat that fluid as continuous. Okay, there is no problem. But in fluid 2, the gaps are little higher compared to the molecule size. Okay, however, we can treat this also a continuous, though there are gaps, but consider there are no gaps. But what is in fluid 3? In fluid 3, the gaps are very high compared to the molecule size. The gaps are very high. The discontinuities are very big. So in this case, the continuum concept is no more valid. But every time it is not possible to say by seeing the fluid molecule size. That's why we need to define when the continuum is valid, when the continuum is not valid. So to understand or to say anywhere or any fluid in order to say whether this continuum concept is valid or not, how? There is one way to explain that when the continuum is valid, when it is not valid, when it is not valid. Take a look at this example. There is a car moving on the road. The width of that car is approximately, that is the front windscreen. The front windscreen is L equals to 1.5 meter. So this is approximately 1.5 meter. And when the car is moving, there are a number of air particles that will approach the car and hit to the surface of the front windscreen and exhibit some drag force on that windscreen. Now in this case, whether the continuum is valid or not, applicable or not, to say that we require two lengths, that is length of that car, or is also called as characteristic dimension L 1.5 meter. One more is the molecular mean free path, that is, as we know already, what is molecular mean free path? The average distance between molecule to molecule, lambda. Here lambda we know for gases 10 power minus 6 millimeter, at almost on the surface of that 10 power minus 6 millimeter. Now if we divide these two, lambda by L, molecular mean free path and characteristic dimension, if we divide these two, then that should be less than 1% for the continuum to be valid. So if we divide these two, that is lambda and L, then if it is less than 1%, then continuum is definitely valid. Though there are discontinuities within the air molecules, but we can treat that as continuous. In this case, definitely it is continuous. Why? Because it is 10 power minus 6 millimeter, it is 1.5 meter. If we divide these two, it is definitely less than 1%. To understand this, take one more example. It is artificial satellite placed at the end of the atmosphere, This is at surface, and this is a satellite. These are solar panels. You consider the length of the solar panel is equals to approximately 2 meter. And there also, even though that the artificial satellite is placed at the end of the atmosphere, there is some fluid. It is not like there is no fluid there. There is fluid, but the density of the fluid is very, very less. And here the difference is the fluid in the outer space and the fluid at surface. What is the difference is the density as well as the molecular mean free path. The molecular mean free path here is 10 power minus 6 millimeter, whereas here it is approximately 0.5 meter. It is very, very high. Lambda is equals to approximately 0.5 meter to 1 meter also. We don't know. Such rarely the gaseous molecules are located from each other. So lambda is considerably high. 0.5 meter is very high. So when this artificial satellite is moving around its orbit, the particles will impact the solar panel at very high velocity, and that will also exhibit some drag force. Here also, whether this continuum is valid or not, to say that we require two, that is lambda and L. If this lambda by L less than 1%, definitely here also continuum is valid. We can say the fluid is continuous. But in this case, for example, what is lambda? 0.5 meter by L 2 meter. It is approximately 25%. So 1 by 4 is 0.25, so 25%. It is more than 1%. So that's why in this case the fluid in the outer space, it is not treated as continuum. With respect to this satellite, it is not continuous. But if we consider this fluid but not this satellite, if you consider this fluid with any another object, say which is very higher in dimension, so in that case sometimes this fluid is also considered as continuous. So that depends on, with respect to this satellite, the fluid is discontinuous, but with respect to some other bigger object, then that fluid may be continuous also sometimes.